Hi, good afternoon, everyone. First and foremost, I must tell you that before getting ready for this talk, I was a little nervous. So I told Ed Scoudis, I'm nervous. And Ed says, Ed, who was our keynote speaker, he says, I'm going to show up to your talk. And I'm like, he's just kidding. He's not going to show up to my talk. He walks in and he's in the room. So I'm a little nervous. I was hydrating myself before getting ready. Now I've got to go pee. It's actually good to see, like, I've got Rich, Jessica, a couple of Rick Minga and other friends over here. So I'm really pleased to see friends. There are others who are over here kind of with a morose look on your faces. I'm assuming that's because of all the drinking and the partying that you had last night. You haven't had the sleep that you needed to be able to be ready for this talk. But nonetheless, thank you so much for coming. It's Sunday afternoon. I'll also confess to a crime. I completely stole this idea of my introduction from Johnny Long. How many of you know Johnny Long, our brother? Yep, so great guy. If you haven't visited Hackers for Charity, please make sure you go and support them as well for the tremendous work that he's been doing. In fact, he's been a huge inspiration to me. So I did steal this introduction, kind of, or the format of the introduction from him. So you may be familiar if you've seen him kind of introduce himself. So my name is, okay, let's see. My name is Manoranjan Paul, and it's not to be confused with Marijuana Paul, all right? Manoranjan means entertainment, and entertainment plus education will give you enlightenment. And so that is my intent today, because if I entertain you and I do not educate you, then I make myself basically a joker. All right. So I looked up thesaurus and I found out as to what some of the words for thesaurus is. One of the words is actually banana. But then if you keep looking, second banana. And then you keep looking, top banana, right? But the word that caught my fancy was the word wisecracker. So I certainly like to be wise. But at times I've got to do this. I've got to do all the stuff that we kind of end up doing for cracking passwords. In this case, running John the Ripper to be able to get some passwords out. I do like to be wise. The Bible does say that he that wins souls is wise. So I am a Christian, and some of you may think that it's leet. Others may think that it's lame. After 3 near-death calls, say what? I'm a Christian. Inspired by Johnny Long and a couple of other friends, including Dave Kennedy, the founder of DerbyCon, who supports us. So we actually founded an organization called Hackformers in Austin, Texas, which is where I'm from. In case you couldn't tell from my tan, right? So it's hot in Austin. So Hackformers got the mission to teach security, to teach Christ, and to teach security in Christ. And so if you're interested in share the faith, feel free to plug in. I also write daily on a faith blog that I write, and that's the address. It's called Hidden Treasures, and it's got a facebook.com get pearls. I'm an author, which is evidenced by some of these publications: the Information Security Management Handbook, the Certified Secure Software Lifecycle Professional, and the 7 Qualities of Highly Secure Software. Once, while presenting for a talk, we're getting ready for a talk on the 7 Qualities of Highly Secure Software, I'm on this flight, and I'm kind of reading my book as I'm making my presentation, and the guy next to me, he asked me, hey, what are you reading about? And I go, something about software security. And he goes, is that book any good? Now, this is my book. So how do you answer the question? Is your baby good looking or bad looking, right? So I answer and I tell him, I say, the author could have done a better job at it. And then at the end of the flight, I gave him my card and then I showed him the authorship of the book, and we burst out laughing. As for my day job, I function as the CEO of Secure Risk Solutions, which is a company that does software security education, like training, do some consulting, and then some product lines as well. But I've got to backtrack a little bit. Now, I know Kali is the new operating system, but you can't like show Kali and then have a back arrow. But backtrack, I've got to backtrack. Before I came to the world of security, I used to work here. Oh, I'm sorry. I used to work here. Oops, that slide was supposed to be hidden. When I worked at Dell, and I used to prevent hackers, I guess some of you guys, from doing this, like SQL injection attacks and cross-site scripting attacks, cross-site request forgery attacks, which actually looks better on a T-shirt than it looks in code. From getting into our networks and things. So I'm an AppSec guy, and then now I'm kind of focusing a little bit on the iOS side as well. But even before I was working in security, I used to work here in the Bimini Biological Field Station as a shark research volunteer for this guy who's the founder of the American Elasmobile Society, Dr. Samuel Gruber. In fact, if you watch closely, some of the episodes that come on Shark Week are the ones that he kind of runs. And so I used to work for him as his research student. And you can say I'm a shark junkie because of all the iPhone apps that I have, which are all like shark stuff. So my friends actually call me the shark, and that's my handle that I have to go with. When I'm not doing shark stuff and I'm not doing security stuff, I'm doing this. Anybody tell me what this is about? It's got like 5 animals and it's got like Chinese characters around it. It's actually Shaolin. This was brought to America by Jiu-Jitsu. Come on, man. You take a stab, it's got Chinese characters in Jiu-Jitsu. That's really, all right. So I do this for, this guy is actually Grandmaster Sin Quan Te, who brought Shaolin Kung Fu to America, and he's over here with me and my son. In fact, I am so proud to report that my son is the youngest Shaolin black belt in America. All right. He was in the news. He's 7 years old. He started training when he was about 3.5. He's a hardworking guy and a good person. So, Ruben. I do have another boy called, he's 18 months, Itai, and my beautiful wife. And my son would continue to remain the youngest black belt in America unless my second boy ends up trying to do something like this. Right? So, love mommy, right? So, my son once asked me if I was famous. Dada, are you famous? Actually, I should say, are you famous, not are I famous? And I was on the news for the Stratford WikiLeaks hack, reporting on the incident because it happened in Austin, and I live in Austin. But also, Google did something a couple of years ago. They got me on the cover page of Playboy. The way they got me on the cover page of Playboy is, it's two individuals, Keith Mano and Paul Erdman, but by the way they ended up actually indexing it, it ended up being Mano Paul. So when you would search for Mano Paul, you would get this as a hit. Trust me, this is not me. But I've got nothing to do with this. So who am I? I'm a Christian author, biologist, CEO, the Shark. I love my savior, love my spouse, love my sons, love Shaolin, love sharks, and I love security. So here we are, Mano the Shark Paul. That's my Twitter handle, Mano Paul. So if you guys are tweeting about this talk or tweeting anything about me, if you say something nice, I'll retweet it. If you don't say something nice, don't say something. Don't not say something nice. Right? So that's it. All right. So here we are to talk about iOS reversing, kind of. Well, what do I do to get it's a play of words, right? iPhone apps or Ipwn apps, and so the tools and techniques. That's essentially what the abstract as well talked about. So I'll focus on the tools and the techniques that you could do to reverse apps, and I'll kind of go over it. Disclaimer: this is only for educational purposes. Like if you're a diabetic in a candy store, right? You can look but not touch, kind of thing. You guys know that phrase? Having said that, though, even though you're diabetic, sometimes we end up having ice creams, right? So take it for the betterment of security. Don't run with scissors, but if you tell that to your child, what do you think they're going to do? Run with scissors, right? I'm not an iOS expert by any chance, nor do I claim to be one. This is stuff that I've done as part of research that I'm going to be presenting. This information, there is other researchers that are out there, they've got much credibility in this, but I don't claim to be an iOS expert. This is my debuting at DerbyCon, and so it's about all in the family, so don't be hating, if it's not information about things that are not directly relevant to you. I do want to give a shout out to Minga. Minga is over here. I know I saw him. He's hiding over there in the back, who's the guy who actually helped me out in getting the necessary the phone to be able to do some of this talk. And I was like cranking code till last night. And Minga, thank you so very much for being willing to offer your phone. Now, having said that, he told me not to say that, but he also used other adjectives to say, hey, don't. And AHA, Austin Hackers group from Austin. If anybody is here, shout out to you guys. You guys rock. So what is iOS? It's the mobile operating system, which was earlier known as the iPhone iOS, and so you kind of from that it ended up becoming iOS. Now it's ported over to the Mac OS. It's kind of using the same code base. Developed by Apple to run on iDevices, iPod, iPad, iPhones. But the key thing to keep in mind, though, is the iOS is actually a layered architecture, which means your applications are going to run on the, it's going to have that as the intermediary to be able to access the hardware resources and back. And that becomes important when we have to decode or decrypt information to reverse some of the apps, because the apps, when you get from Apple, comes down in binary formats. You don't have source code to work with. Also, you don't have, it comes in an encrypted state. So Apple signs the apps before it actually comes to your app, this one into your iTunes folder or whichever way you get it. And once you have it, if you go and just try to extract some information out of it, you're going to see that it's encrypted. So we need to literally get into iOS, see it in the operational state, and then take a memory dump to be able to get that information out, and then almost like binary edit the file to be able to see what we can to decrypt the information that is encrypted. So we'll kind of see some of that. It has local storage. SQLite and manage object model are the two main ones in which they actually store local storage. Most of the apps, if you just go and kind of do a zip it and then extract it, there'll be like SQLite databases that you would see that you can go ahead and browse through and get some information and data out of it. Talking about reversing, what is reversing going back in the life cycle? We kind of have the code now, and we're going back to concepts. We develop apps from concepts to code, but we go back in the life cycle in terms of going from code to the concepts itself, and you need some tools and some techniques. In the context of this talk here, I'm going to focus more on discovering information. I'm not going to go into more of the tampering aspects other than just kind of patching a binary or so to be able to get some class information out of it. The tampering aspects and the patching and then the signing of the application so that you can reload it and run it back in your devices itself is, I haven't gotten ready for that, to be honest, but also that is the talk that I'm going to expand on at LastCon in Austin. So if you guys are going to be coming to LastCon, then you catch me over there with the rest of the talk as well. If not, plan to attend because it's a great conference in Austin. And I believe it's on the end of October timeframe. So, all right. So iOS reversing some of the prereqs, you need a jailbroken device or an iDevice. You need some software, the application itself that you're going to actually try, the target application that you're going to try to. A lot of coffee, some Red Bull, booze, maybe a combination of all three, but when you drink, drink in moderation. So whether it's coffee, Red Bull, or booze. Lots of long nights of just looking at code and other things as well. So the tools that essentially I'm going to show over here, like this standard SSH, the class dump tool to be able to get class information out, Xcode Tools. Xcode actually comes, you got to go and get the OS developer kit, and then you have the tools. O-Tool is one of the main tools that we use to do a lot of the research on the iOS apps itself, and then some custom scripts. If we have time, I'll probably also show you a script that I've written, and most likely I'll put it on. I'll give it up on GitHub at the end of the talk. Within the next week or so, it'll be up. It's not there yet, but it will be, and I'll give you the details. So in terms of the technique itself, install the target app on the iDevice. For a Mac OS or so, you could do iTunes, or you could use iFunbox. Anybody use iFunbox? One gentleman over here. So iFunbox kind of helps you in terms of being able to get apps over there. Also see a lot more information than what iTunes will allow you to see. Or if it's on the device itself, you could use the install IPA software to be able to do it. Now, in terms of the setup, the way we go about is, first and foremost, the target app that you take, you put it into a backup directory. Create a directory just so in case you're going to mess with it and it kind of, it goes into a corrupted state, then you have some way to recover. Then often I do it as just good practice to be able to copy the app from the application into a software, into some directory like reversing or so. And then we rename the IPA itself into a zip file, because essentially it's actually just a zip archive file. The IPA extension is an archive file. Once you zip it, you can unzip that file. Once you rename that extension to zip, you can unzip it and you can get a lot of information. In fact, the payload gets extracted on once you unzip it. The place where you actually get the file from is if you're getting iTunes, and there's a mobile iTunes, music, media, mobile applications, and you'll see all the files. I'll kind of show that to you as well. Once we have that in the reversing file, we try to do a class extract using class dumpz. When we do a class dumpz, what you will notice is you're going to most likely get this reported. The terminal is going to tell you that warning, part of the binary is encrypted. Usually the result that you're going to see is going to be not very meaningful, and try to provide an unencrypted version instead. So that's kind of the intent of this talk, is to be able to get to that unencrypted version to be able to then go and extract class information from that binary itself. So the way you would actually want to verify if it is truly encrypted or not, if you open actually the file that you just try to class dump out, you'd end up seeing something as the protocol which says XX encrypted protocol, and so you know that it is encrypted. Now, in order to provide the unencrypted version, step one is to first determine the architecture in which the app is going to run. For us to be able to do that, we use the O tool with the VH switches, and you give it the app name. What you would notice it gives you the, for those of you who are going to have difficulty reading from the very back, it says ARM7 and ARM7S. And then on the very right hand, it says PIE. PIE is position independent encryption. It is similar to ASLR in the Windows operating system. So every time this app runs, it's going to have a different starting address. So you've got to find that the base address. You've got to find that base address to know as to where you're going to get that information to dump that information from. And we kind of have to see that. So we first need to, we know that it's encrypted. We know that it's also going to have, it's having like ASLR-like protection. So we have to really go into runtime and to be able to grab that information to put that out. So we determine the architecture. And once we determine the architecture, we need to find the cryptic information for that architecture as well. So the crypt info is essentially where I could just do a O tool L, and then I could give the app name and load all the commands, and I can search for the LC encryption info module, and it'll tell me if it's crypted or not. In fact, if you notice, it says crypt ID is 1, or I could just do a grep on that and then give you just the crypt information. It's important for us to see this and know this, because we'll use this as we go through in reversing the app itself. We then replace the crypt ID in the binary, because what we do is you find the crypt info. Once you have that information, you take the binary itself and you open it in a hex editor, and we replace that crypt ID. The reason we do that is when we get the dump out of memory and we put it and we overwrite this binary with the dumped memory, it's in decrypted form. So you don't need to decrypt it anymore when it runs. So we've got to go back and remove the crypt ID and change that flag from 1 to 0. But we need to find out, if you open a hex editor, where the heck, right, is that crypt ID in a hex output. So to find out that information as to where that is, initially when people are doing this research, they were like, just take a swing at it and see wherever you have 0, 1, and kind of do the coin flip method. But there's a more structured methodology to be able to find out where exactly that crypt ID is. The way you go about finding out is, earlier you would have seen, if I'd gone, you saw over here in this place what the command size is, what the crypt offset is, what the crypt size itself is. So that gets represented in hexadecimal form as the command is 21, the command size of 20 is 14, and then the crypt offset is 8192. That's essentially the hexadecimal representation. The hexadecimal representation of the 8192 in binary form is going to be it's the 2000. And then the crypt size is over here, it's 4177920 in the binary form, which in the hex form is essentially going to be 003FCO00. And then the crypt ID is the one exactly after that. So what happens is, when you ask and you seek, you will find, you seek this string, 21, 14, 2000, and then whatever the crypt size is in any of your hex editor, and you would notice it'll be out there, and the very one following that will be the crypt ID of 01. I'm sorry, it's hard probably for those in the back, but you know that that is the crypt ID that I need to go and swap. So we go in and then make sure that your editor is in overwrite mode, and then you change that flag to a 00. So in order to verify that information, then we would go about save the binary, verify it by running that same tool, otool-l, and then you would end up seeing that the crypt ID is now 0, the same size remains, the same offset is in for that binary. So we have the binary that is now in a state that it needs now the decrypted information to be able to so that we can then extract class information from that itself. But in order for us to do that, we need to get that running from memory. So we need to go to actually SSH into the app, into the iPhone device itself or the iPad device. You need to run the app so that you can actually attach yourself once you find the process ID. To find the process ID of that running app, use the just ps-ax grep, find the process ID, in this case it's 318, and then we do attach a debugger, GDB, to that process ID. Once the symbols have loaded, we essentially go back and run this info shared library. Now, the reason why we do this is info shared library will give you the base address, which in this case is hex 1E000. Now, if you notice, if you just go back and look at the load commands, what you will notice is in not runtime mode, when it is static, the virtual memory address is actually not 1EX00X hex 1E000. Instead, it is 1000. Now, this essentially would seem like it is the starting point for the app, but when you try to run this and you try to actually read off from that address space, it would tell you that you cannot read memory from that space. So that is not the base address. The base address is essentially, now this is making me extremely nervous. So the base address is, you done? Oh, God. At DEF CON, they get you these drinks which kind of loosen you down. Where are the drinks at DerbyCon? All right, so we actually have to go to find the starting base address, and that is done from runtime, and that's why I run the info shared library to get that value out. Once I get that value out, then you basically do a dump, right? But in order for me to do a dump, I need to do a little bit of cryptic calculations. So I've got a base address, but there's also an offset. So the offset place the base address is going to give me my starting address as to where that application is actually running in memory. So I have my starting address. Now I need to find my ending address, but good thing from the previous research, we found out that it gives you a script size. So you have your starting address, which includes your base address plus your crypt offset, and then you have your crypt size, which will give you your endpoint. So you have your starting and your endpoint, and now all you need to do is what we do pretty much every day. We have to take time to take a dump, right? Well, in this case, we're taking a dump from memory, and I'm sorry. I'm nervous as shit. I don't even know whose water that is, but I probably am going to drink it. So I take a dump from memory, and I essentially write it into a binary format, and then quit from the debugger itself. So once I have that, I've got to transfer that dump over to my iPhone device, and I could do a secure copy and a CP over to my device. And once I have that information on my device, now I've got to patch the app. So I've got the app, I've got an already edited kind of app in my device, and so I'm getting the dump, which is just the binary dump, which is going to match the exact same size of whatever information of that app was when it was running in memory in decrypted form, since the dump file is actually already in decrypted form. So I copy all from that, and then I go in to find a starting address in my application itself, or in the binary on my device, to be able to write over. Now, the reason why I told you to pay attention to that virtual memory address, thank you so much, man. God bless you. And God bless America. Actually, I just became a recent citizen after a lot of paperwork and all that stuff. I have been detained in Brazil, but that'll be a talk after on by itself. It was the best thing is you get detained. The best place to get detained is Brazil, right? So, thank you so very much. So I told you to pay attention to that virtual memory address, but because right now we're no longer in operational mode, we're now in static mode. So the virtual memory address of 1000 is now calculated, and it's computed along with whatever your offset is to give you 1000 plus 2000 as the offset will give me the hex address of 3000, which is what I'm looking for. And in my binary editor, I'm going to basically overwrite that content from that I took the dump from the phone itself. So once I have that overwritten, you go back and you extract the class information from the app, you run class dump z, and what you would notice is what looked like this would end up looking to your right with a lot more information that you can go back and research, and then find out what APIs are there, what web calls are being made. In some cases, you would find actually hard-coded strings with connection information, and it just gets interesting after that. So that's kind of to the point where we are. And so let me see if I can do a demo quickly for you. Maybe, okay, before we get to that. So let's go to the demo. And what I'm going to do is kind of walk through that same process. I have here on my desktop a folder called DerbyCon demo. I set up a backup just as good practice, a folder called reversing. There's nothing in those folders right now. And let's go to music, iTunes media, mobile applications. I'm going to grab this app over here, the Run a 10K series, and I'll tell you later as to why I choose that app. Go back into my desktop, DerbyCon, backup, paste that in the backup just as a good measure in case I need to work with it. Then I'm going to copy that same file into my reversing directory, paste it in the reversing directory, and I'm going to name this so that there's not so much of these runner R10K. Let's just say that. Once I have that R10K, I'm going to rename this file into its zip folder. It's going to tell me you want to use zip. Yes, I want to use zip. And then I unzip that folder. The moment I unzip that folder, I get my payload. Sorry, that's not what I wanted to do. I get my payload information, and then in my payload, I'm going to actually have the app itself, but it's a bundle. So I'll have to go and show the package contents for this bundle. It's more like an archive. And once I show package contents, it's going to give me all the information. The actual executable is over here down with the same name as the bundle. And so you'd go and grab the runner 10K free app. So I'm going to copy this instead of having to navigate through all these directories back to that reversing folder from the payload. One more, I think. Okay. Back into the reversing folder. I'm going to just paste this information. Now, as I said, if I was to run, so reversing runner 10K free. So open up your terminal. Let me see if I can make this a little bit bigger. Is that a little better? Yes. Yeah. Okay. So navigate to that directory. Actually, I'm right now. I'll open up another terminal here. So CD to desktop, DerbyCon demo, reversing, my app is over there in that. So if I just do what I said, like I was talking in my talk, if I do a class dump of that app and I run it, it's actually going to tell me as soon as it runs, as I go up, a lot more, I guess. You know what? I'll do it the easier way. Let's actually just write it off to a file on a 10K. Class info.txt. And it tells me what I told you. Part of this binary is encrypted. Usually the result will not be very meaningful. Try to provide an unencrypted version instead. And in order to verify that, if we just navigate to our folder, you could open that file in your text editor, and that's what it's going to tell you. It's going to tell you that this file is encrypted. It's not anything that you can really see inside that file. So in order to give an unencrypted version of this file, go back to the terminal. That's my terminal. There you go. And then I need to do to determine the architecture first. So O2 VH. And that gives me the information I showed you, but I've got ARM7 architecture, ARM7S architecture. Or if you go scroll down a little bit to the right, you should also see, actually it's over here. It's got the position independent encryption. So we have it still in encrypted state. We know that it's encrypted. So at this point, I need to start loading commands to find out what this, I'm going to just say, load commands, text. It's going to write out a file there, and then I'll also show you the crypt ID. So here you see 8192 is a crypt offset for this binary. The size of the file, the crypt ID is set to 1. And so this is what we'll be using to be able to find this base and the starting and the ending address. Now, in the file that I just wrote out, the load commands, if you navigate over to the, let me see if I can make this bigger here. If you navigate over to the load command 1, I was talking about the virtual memory address, and that is set to 1000. And so the address that we can't actually access because it's a static address. And so we get that information over there, and then if you actually go down and search for LC encryption info, you'd end up seeing the other information that I just showed to you in the, I think it's like load command 21 or something like that. There it is. The LC encryption is 11 actually, load command 11, and then you've got the command size and all this information that we'll be using to be able to do the binary edit. So now we go back to, so I've got some class information, I've got some crypt information, I go back to, in fact, let me write that out to, it's my terminal. I'm going to write this out to the runner, okay. And we have that information for use later. Once I have the crypt information, now I go down to actually editing the binary itself. So I'm going to go open this in a hex editor. And you could use like 0xed or like hex edit. I in fact use probably both in this demo. And in the binary editor, I told you we need to look for that string. So the string that I'm going to look for is 21, 2, 4, 14, 1, 2, 3, 4, 5, 6, 0, 0, 2, 1, 2, 3, 4. Let's see if that finds it. Well, there was something wrong with that. Let me just search for 21. Okay, all right. So just loading the binary form for that LC command structure gives me 21. I know it's a little difficult for you guys to see, but I see over here that that's the crypt ID that I'm going to change from 1 to 0. Make sure that it's in overwrite mode. So the binary editor is in overwrite mode. You end up doing 0, 0. And we found it in 2 architectures, so we'll do it for both. So find the next one, 14, 0, 2, 3, 4. And in this case, that's the first one. Find the next one. There it is. 0, 0. And then I'm going to just save this file, and let's just save that as in the reversing, run a 10K, maybe like patched or something. So it doesn't have the crypt ID set anymore. In order for me to verify that, I just go back and run the otool command on the patched app. I think I did not write it right, so let me see if it is. So that is not going to work. Give me 1 second. The cardinal sin of trying to do a demo on stage, right? So, okay, that is good. Let's do this again. Oops. I'm going to open that again and try to. Okay, so I've got one there. Let me see the other one. Okay, all right. So this is the one I need to overwrite. And I need to overwrite. Now let me save this file. And go back to the terminal window. Okay, there you go. So I think I typed in a little too many zeros and it kind of corrupted my hex file. But now we have it back here. You see, actually, the crypt ID's offset is changed from 0 to 1, so it doesn't need to decrypt the information anymore. So we have this information here. Then I would have to actually go and get the memory, the information from. Now I have to get the binary dump from the phone itself. So let's see if it's still running. It's connected to my so I SSH into the phone. I'm there connected to my phone. And on this phone over here, I'm going to just do a PS. Grab of all the apps that are running. In fact, the app that I'm supposed to be running is not running, so we'll run that app. And once the app comes up, you should be able to see when I do this, the app is running, the Runner 10K free app is running on process ID of 6350. So I would then attach the debugger to 6350. Is that right? And then once it loads, we'll get the starting address. You guys have anything interesting to talk about while this loads? Done. All right. It's going to do a little bit. Okay, and so this is what I was saying. So if you try to actually go and read off that memory, as I was saying, from the virtual memory address, you're going to get that cannot access memory. So I need to find out what that memory is, and info shared library would give me all the libraries loaded. The very first one, actually, so this is a pretty big app. It's got tons of libraries that's supporting libraries, so it warrants a lot of research, I guess. But you notice that the address over here is the one that we need, the starting address for this app, the Runner 10K app, and it tells that this app actually loaded in memory at that location. All right, so that's the base address we've got, but we also have to deal with the offset. So in order for me to get a dump of this memory, and let me actually copy that memory address, 0, this one, and I have a helper worksheet actually that I will open up here. Helper to do some cryptic calculations, and the base address, I'm going to change that to 0xb. We have the crypt ID, we have the crypt size, which was the one for this app. I'm going to take this, starting address is going to be that, so we need to find out what the starting address is going to be here. Ending address is going to be base address, which is this information that we got, and then the ending address is something that we need to compute. So before we come down to that, let me go back to the terminal and see if we can read off memory from that address. So 64 bytes of memory at that address, and we can read. So we have access to that memory to be able to pull that app in binary format and then now do an override. But we need to see from where to where we need to dump that memory. And in order to do that is why I went to this workbook. And that's not the one. Where's my text edit? There you go. So doing some cryptic, it's really not cryptic, it's just hex addition. So base address is this, base address plus offset, mac calc, go to, you pretty much use any calculator to be able to go to BE1, a couple of zeros, plus 2000. That should give me zeros, hex 6C, hex C, and that's 4 zeros, 1, 2, 3, 4. So that's my starting address. In order to add to get the ending address, then I do this base address plus offset, so base address plus offset, so whatever the crypt size was, and the crypt size over here is represented hexadecimally to be this value, which you can convert from the binary form you'd find once you get the once you do the grep of the crypt info from the binary, and then we add that to get you. So essentially the ending address is 4BC 1, 2, 3. So I've got my starting address, which is going to be plugged in here. I've got my ending address, and now I can dump memory for that app and write it off to a particular, to just run free decrypted.bin file. So go back to GDB, make sure I can still read from that address space, BE. Okay, I can, and so we will run dump memory from the starting address to the ending address. And we can quit GDB at this point, but before I do that, let me actually just go back and open another, my other window. All right, so quit. Yes, I want to quit. Detaching from the process, ls, and it has that binary that's been dumped. Now, if I just do an LSL on that, that binary information should be exactly the same size as to what that crypt size was, so that you know that you've got what was decrypted in memory as the same amount of data that you've now got. So essentially I could use like a fun box, or I could just do a SCPR and then runner, just copy that to my local box. I think I don't know what my 192.1. Okay, 164, and then move it to the users. Paul, desktop, DerbyCon, demo, reversing folder. I think that is all I need to give. It's going to ask me for my password. And it's going to transfer the file over. So at this point, we really don't need the phone anymore. We've got the information back on the device, and so I could exit out of this, and I can go back to the device itself, and so I have the decrypted bin file. Again, just to verify that all of the data got transferred, you do the ls, you'd find that the same file, decrypted bin file, is the same size as that of the one that we copied over. So we got all the data over in binary form. Now we open up the hex editor we actually, this is the patched app, so let me leave that open. And I'm going to now go back to the folder, and I have the bin file. I'm going to open up because I need to copy that as what is going to be used to replace. I'm going to show you the other editor I use. Control A, Control C, copy all that information, open up the patched, open with. Now this is where I told you that I need to use since this is in static, I need to take the virtual memory address, which is 1000, take the crypt offset, which is 2000, and add it together to go to that offset of 3000, because it's not running. Otherwise, I'd have to use if I was doing this in the phone itself and doing a DD seek and do a dump on that and overwrite in memory, then I would have to use the base address, which we discovered earlier while it was in run mode. But since I'm doing it in static mode, I'm going to have to go to the offset of 3000, which is right there, and then I'm going to paste all that information that was there in memory from this. So let me copy that, and we paste this information. So we've overwritten the file. You kind of already can see there is some information over here, and it's kind of ironic. This app doesn't have permissions to do this, is what it says. So, for what it is worth. So we then go back and save the patched app. So once we save the patched app, I should go back to this, and it was at 148. It was saved over here. Okay. Now when I go back to this and I run the class dump on the patched app itself, what did I call that? There it is. Okay, so class dump z, Mano, 10K free. I get the load. Actually, let me show you. So I'll write that out to a file. It's easier for us to process. So runner 10K free. And we'll write that as DerbyCon patched text. And then once I open that information, DerbyCon patched has got all the information of all the class files, which earlier which showed us as unencrypted form. So at this point, it's time for you to go, play around with the app and discover more information. So we've got this to the point where we've discovered information. I'm not going into the patching because it needs more time. Having said that, I also want to tell you, I told you about a script. You saw all the stuff that I was doing. The script is not ready yet fully. I was working till about 6:15 in the morning all night to finish some of the scripts for us to see if I could get it on GitHub. I'm not fully sure. I can release it now as it is, and you guys can go play with it, but within a week or so, I promise to get it out there so you guys can take. The script essentially, so you saw me do all this stuff, and I'm like, I have to do this every time for every app. It's getting kind of onerous, so let's see if there's some better way to do it. And so I'm going to just copy this one out in case we need to use it. Just the patched version of the app, but other than that, let's go back and clean up. So I'll keep the backup in the backup folder. Let's clean up all this stuff. Okay. Deleted all that stuff. I'm going to grab from the backup folder. No, let me just double click that. No, I don't want you to. Right? So copy, move that to this folder here, run. Okay. And that's the name of the app. I'm going to try to reverse. And then we go open up. Where's my terminal? Okay, so I'm going to clear all this. I'm going to actually navigate to my dot. Users. Xcode Tools, mobile, iOS, scripts, and so there's a script over there, a Python script, iOS, app reversing.python.py. It's going to ask me the directory where this app is, so we'll grab that so we don't. So just the directory is where I place the app. Give me the name of the app that you wish to reverse, and that is going to be, I think I called it run10k.ipa. It's creating a backup directory, creating reversing, copied it, and it runs all that stuff that we were running manually over for you. So I put it on the terminal output so you can see it to the point where it gives you the information as to grabbing all this. Then you would go about doing the binary editing, which also can be automated. Just didn't have the time to, but we can extend the script to be able to do that, to do the binary editing of the file itself in Xedit mode. And then once you have it, then there's a secondary part of the script, which is so you'd actually notice it created a folder, it created a backup, made a copy of the file, reversing, it extracted the payload. It's got all that information over there for you to look at, and then it does the commands automatically for you. So once you have that, then I would actually show you the second part of the script, which essentially is the Python iOS reversing class extractor. And this is going to ask you for the name of the app and the path, and I'll give so once you've done the editing, you would have this in patched form, and that's what you would drop to that folder as an input, and you'll run it, and it'll give you the information. So from unencrypted state to encrypted state to discover information, and at this time you have not just iPhone apps, but you have iPwned apps. That's all I have to say. In fact, I'll put up my information over here. So the demo is done and good, kind of went okay. GitHub.com, Mano, Paul would be the one that you would go to. Don't go there right now and see it. It's not there. It will be there, I promise. If not, the way you can get a hold of me. So if you like the presentation or you did not like the presentation, if you have some security program development needs, product development needs or evaluation, or you have awareness training education needs, then you can contact me. Else, have a great day. It's about all in the family. And finally, thank you. The way you can get a hold of me is on LinkedIn, Facebook, and Twitter. You usually just see that sign of the shark with the name Mano underneath it. So that is me. And then you can contact me by email at mano.paul@securisolutions.com. So thank you very much. You guys have been a great audience. Appreciate your quietness. Thank you so very much.